We are from Group 11. Our group members are Choong, Lim Ruei Wen, and myself, Ooi Shin Yi. In this task, we are required to obtain the simplest Boolean equation using EVM method, with z as the entered variable for this function. We also need to implement the function using 4 to 1 and 2 to 1 multiplexer only. In this video, Choong will explain about question 1 while Lim Ruei Wen will continue with question 2.
Alright, for question 1, we can highlight this important equation as shown below. So with this highlighted equation, we can move forward with the truth table analysis. Basically, for all these numbers here, we will have to put 1 to them. So at 2, we will have 1. At 5, we will have 1. At 6, we will have 1. At 7, we will have 1. At 9, we will have 1. At 12, we will have 1. At 13, we will have 1. And lastly, at 15, we will also have 1. And the rest, we just put 0. Now we want to determine the EVM value. These two are 0. This is 0, 1. So we stick to 0. And next, this is 0, 1. This is 1, 0. Totally opposite. So we have Z prime. This is 0, 1. This is 0, 1. Same. So we have Z. This is 0, 1. This is 1, 1. So we stick to 1. This is 0, 1. This is 0, 1. Same. So we have Z. This is 0, 1. This is 0, 0. So we stick to 0. This is 0, 1, this is 1, 1, so we stick to 1. This is 0, 1, this is 0, 1, same, so we have Z. With this truth table analysis, we can now proceed to the 3-variable K-map. For 0, 0, 0, we have 0. At here, 0, 0, 0, we have 0. This is 0, 0, 1, we have Z prime. 0, 0, 1, Z prime. 0, 1, 0, we have Z. 0, 1, 0, we have Z. 0, 1, 1, we have 1. 0, 1, 1, we have 1. 1, 0, 0, we have Z. 1, 0, 0, we have Z. And 101 we have 0, 101 we have 0, 110 we have 1, 110 we have 1, and lastly 111 we have Z, so 111 we have Z. And now we can determine the Boolean equation, but this is the complicated one. So how do we simplify it? We apply 1 equals to Z plus Z prime, also equals to Z prime plus Z. So we go back to the previous slide. Now, we change this 1 to Z prime plus Z. We also change this 1 to Z prime plus Z. And at here, we can get 4 different color data. And this data will be the final answer. We can also check this answer using the 4-variable K-map. As a result, we get the same answer. It is worth mentioning from the 3-variable K-map, right? We can understand that this Z actually has 3 functions. The first one is that it can work with these 3 Z to form the orange data. And then this Z can also work with the far distance Z to form the blue data. And lastly, the third one, this Z can work with the Z prime. As understood, 1 equals to Z prime plus Z. So this yellow dotted data is understood as 1, and we can get this yellow data. Lastly, all of them plus with the green data and form the final answer. So coming back to the question, we answer this question, the simplest Boolean equation using EVM. So the answer is, as shown here, the highlighted equation.
Next, we will come to the second question. We implemented this function by using 2 4 to 1 multiplexer and 1 2 to 1 multiplexer, and we arranged them as shown in this diagram. This is the 2 to 1 multiplexer with 2 inputs, 1 output, and 1 switch. As for the others are the 4 to 1 multiplexers with 4 inputs, 1 output, and 2 switches. According to the EVM of the previous question, the 4 inputs of the first 4 to 1 multiplexer are 0, Z prime, Z, and 1. As for the second 4 to 1 multiplexer will be Z, 0, 1, and Z. We declare the switches of the 4 to 1 multiplexer as X and Y. The output of the 4 to 1 multiplexer is the input of the 2 to 1 multiplexer, and we declare it as W. F is our output. There is an extra knowledge for 4 to 1 multiplexer. We need to refer to its truth table to decide the input it chooses. As we can see, the variable W is playing a role of most significant bits, and the variable y is the least significant bit. So, by refer back to the previous truth table, we can apply it in this diagram. When wxy given is 0, 0, 0, the input will be 0, and when the wxy given is 0, 0, 1, the input will be z prime. Same go to when wxy equal to 0, 1, 0, the input will be z. And for the last one, if wxy is 0, 1, 1, the input will be 1. Same operation for the second 4 to 1 multiplexer. When wxy is 1, 0, 0, we will get the input equal to z. And for wxy is 1, 0, 1, the input will be 0. And if wxy is 1, 1, 0, the input will be 1. And for wxy is 1, 1, 1, the input get will be z. That's all for this video. Thank you.